So we are dealing with problem number 1.23 of the Irodov solving series, and the problem is stating a point moves rectilinearly with deceleration whose modulus depends on the velocity v of the particle as a equals alpha root v, where alpha is a positive constant. At the initial moment the velocity of the point is equal to v naught. What distance will it traverse before it stops? What time will it take to cover the distance? So this is the problem that we have, where the problem is stating that it is having a deceleration. So if the deceleration is mentioned in the problem, so if we are writing acceleration, so we are writing it as minus alpha root over v. Now it is also given that initially, that is we can say at t equals 0, so initially the velocity of the particle is equal to v naught. So what distance will it traverse before it stops? So we begin this problem by writing acceleration a, which is equal to minus alpha root v, as a equals dv by dt. So dv by dt can be written as minus alpha root v, and from here we can write dv by root v is equal to minus alpha dt, and then we are integrating both sides. So at t equal to 0, the initial velocity is equal to v naught, and at a certain time t it will have a speed v. So from here we will obtain the time variation of velocity for this particle. So we obtain v to the power minus half plus 1, or v to the power half, divide by half, or 2 will come up, and then we have a upper limit and a lower limit, v naught and v, which is equal to minus alpha t. So over here we get twice of root v minus root v naught, which is equal to minus alpha t, and if we calculate the time when it stops, so t equal to t when the particle stops, that is v becomes 0. So therefore from here we get twice of, so root v becomes 0 minus root v naught is equal to minus alpha t. So over here we can chop out minus sign, and we get the time when it stops. So time when it stops is turning out to be 2 root over v naught by alpha. So this is one part of the problem which we have solved. Now apart from this, the problem is also asking us to calculate the distance which it covers before coming to a halt. So now we will be solving the distance which it covers before coming to a halt. So we are again solving the same expression, that is we have a equals minus alpha root v, that is the value of deceleration that we have, and we are writing a as dv by dt, which we are also writing as dv by dx by dt, following the chain rule, so that we can solve for x, which is equal to minus alpha root v. So over here if we write dx by dt as v, so we get v dv by dx is equal to minus alpha root v, and over here on solving we obtain root v dv is equal to minus alpha dx, and again we integrate both sides. So this step is very important. We have been trying to understand this kind of a step every now and then. So since over here the question is asking us to calculate the dx value, or the total distance it covers before coming to a halt, and in this parameter we have dv by dt. So in order to introduce this problem with this parameter dx, we use chain rule. So whenever something like this is there, we will always use chain rule. So over here the next step which we have is very simple. So at t equal to 0, when the motion starts, the velocity is v naught, and at the time or the instant of time when the velocity becomes 0, it has already covered a distance s. So over here on solving we obtain s equals 2 by 3 alpha v naught to the power 3 by 2. So 2 by 3 alpha v naught to the power 3 by 2 becomes the final answer for this particular problem, or the distance which the particle covers before coming to a halt. And this was problem number 1.23.